62?
Still a Roblox character.
Sound like a caveman. Alright, so on number 62, you see there in the book, it's two forces are acting on the ring in figure 22. What is the net force acting on the ring? So in this case, there we're looking at it.
This might be the best line you've ever read.
Good job,
You know what the worst part is? My arms are so sore. Like,
From what?
well, me and Mary decided that.
Oh, what?
I'm kidding.
Wow, that's inappropriate. We decided to make a good health decision, so we got membership down at Silverback. And last night after the game, we went and worked out.
Heck yeah.
And I have not worked out in so long. I literally worked my chest and shoulders, but I have not worked out in so long that for me doing butterflies,
Crispy.
my biceps are sore.
Hold on, by butterflies do you mean
Like the
like
up and down.
butterflies or lay down butterflies?
I did
Connor
machine
is-
and I did lay down dumbbell.
Yeah. That'll
So,
get you.
we have these two forces acting on this ring. So here's the first force in red. We have is 400 newtons. Now this is the thing, to try and get you used to it. 400 newtons is the magnitude. Now direction is going to change a little bit here. Your direction is 50 degrees off that x-axis. In everything that you're doing, it's going to be based off of going from this x-axis to give direction. But you're not going to solve triangles like that. We're going to solve right triangles.
So
Because
does it? Will it always give you like this like diagram of the thing?
no,
It won't.
no.
What about?
You have to make
So for example, like here for 500 newtons, but it's at 40 degrees.
I don't think you went to the talk.
Alright, so now in this we're trying to find the net force. So in order for us to find the net force,
I can't find my book. Where's the extra?
are you sure it's not sitting in a desk somewhere?
It was sitting in that desk. I never moved it.
Is it the one that I gave you at the beginning of the year to take home with you?
It's the one that you assigned me that I sat in that desk right there.
Okay, but I gave you different ones. I gave one for you to actually take home.
Okay, well I didn't take one home.
Okay.
Well, then you've lost 2 books.
We will find it. Alright, so the F net. Okay, this is going to be a single number. But on this, what we're going to find is we're going to find some value, the magnitude, which will be the number, and that'll be in newtons. But then we'll have it at some angle. In order for us to do this, we need
Gravity.
the net force will be equal to the square root of.
Oh.
Please do not get too carried away. Okay?
I'm already carried.
Jesus Christ.
Net force in the x direction squared
What's the A stand for?
At.
Oh, what? Oh my goodness, why couldn't I have
and
written that?
plus the net force in the y direction squared, and that's all under the square root. For those of you that haven't,
So technically, it's just the net force of the x plus the net force of the y.
squared together the square root.
But if you're taking the square root of both of them,
Yeah. Wouldn't that just be?
It'd just be F net.
We're not multiplying. You can't break it apart like that.
Oh.
This right here, when you see an addition sign under a radical, you cannot break that out.
well,
Golden rule, you cannot break it out.
Well. will
Dr.
it give-
Silver warned us 1500 times.
Will it give us what the net force is?
Sometimes it can, sometimes it won't. In this case, I didn't. So I'm asking you to find it, but we give you a way to solve for it.
how do we find that force?
So, perfect example is sitting here when you look at it, what do you have? We have a hypotenuse and a hypotenuse. Well, what do you mean a hypotenuse, Mr. Hall? Look right here.
We use SOHCAHTOA, don't we?
That's exactly what we're going to do, but we have to have the subvectors. So there is this force in the x direction. So I'm going to call this force 1 x direction.
Fix.
And this is force 1 y direction. Because right here's the right angle. Now here's the key. Be careful whenever you're using these functions and make sure you're using this angle properly. This is the angle we're going to read off of. If you want to flip and do this angle, you can solve for that angle, but that's just more work. Now it's the same thing over here. This is force 2 y direction. And this is force 2 x direction. So in this, where we have to find the net force in the x direction, the net force in the y direction, the easiest way for us to do that, you need to think of, is the net force in the x direction, the summation of all the forces in the x direction, the net force in the y direction, the summation of all the forces in the y direction. So we break this into these components and break this into these components, then we can add these together and we can solve around for it. So what I'm saying is let's find force 1 in the y direction. Whenever I look at it, I'm trying to find force 1 in the y direction, so that's opposite. So I'm going to use the sine of 50 degrees is equal to opposite force 1 y direction divided by hypotenuse, which is 400 newtons. So then I'll find force 1 y direction is equal to 400 newtons times the sine of 50 degrees. Make sure your calculator's in degree mode. I get 306.4178 newtons. Now here's the thing you got to think of in this case. This force is going up. So should this be positive or negative? Positive. This should be positive. I haven't labeled nothing out as positive and negative because I'm practically looking at a normal Cartesian system. So I'm leaving everything the way it normally is. Now we need that force 1 in the x direction. Force 1 in the x direction. That is adjacent, so that's a cosine of 50 degrees. And that's equal to force of 1 sub x divided by 400 newtons. So then force 1x is equal to 400 newtons times cosine of 50 degrees.
I have no idea.
It's just tricky.
What mode is it supposed to be in?
Didn't have
Degree?
Degree. We will not deal with radians in here.
Okay.
How
For now.
do you know what one you
Wait.
want cosine or sine?
How do you do trig?
Okay, when you go here, you see this angle?
I do.
Okay, I'm trying to find this. So
Oh.
in terms of that angle, what side is that? That's the opposite side. Here, for the x direction, this is the adjacent side. So the opposite is sine, adjacent is cosine. SOHCAHTOA.
Opposite is sine. And the adjacent, no. Yeah. Okay.
Okay, so I got to do the same things over here for the force of 2 in the y direction. Hold on, that force of 1 in the x direction. I got 257.1150 newtons. Should that be positive or negative?
What is it?
Positive, because it's going in the positive direction. Alright, so force 2y. In this case, I'm coming from this angle, trying to find force 2y.
What angle? So, Mr. Hall, if it's going that way, it'd be negative, right? Because it's on that side of the axis.
Which one, x or y? X. So I'm here. If I went left on the x-axis, those are the negative numbers.
Okay, so like, see how we got, how you just asked us if it would be negative or positive? We said positive because it's in that direction. So if we
Yeah.
go, and we're doing this one, it's going to be negative.
The X direction.
But I'm doing the y right now. The y is not going to be, but the
The
x
y
will be.
won't be.
The y won't be because the y is still going up. But you're thinking right. I just didn't want to make sure I didn't want to confuse you and say yes, and then you say I thought you said it was going to be negative. But I'm dealing with the y. The y is staying in the same direction. But you're right, Christy. In the x direction, absolutely.
Okay.
So then as we're coming off this angle, trying to find that. This force from that angle is opposite side. So again, we'll use the sign. But this is 40 degrees is equal to force 2 sub y all over 500 newtons. Don't get so caught up on the force 2 sub y thing. I just labeled it. If you wanted to, you could have called it force
Y.
apple.
We just do 2y.
It don't matter. It's whatever you want to call it. So then in this, force 2y equals 500 newtons times the sine of 40 degrees.
Well,
Let's multiply both sides by 500.
gotcha. The sine of 40 degrees?
Yep. So we're solving based off that reference angle. So in this one, it's 321.3938 newtons. Should that be positive or negative?
Positive.
Because it's in the positive y direction.
Yeah.
We should keep it positive. Is everybody good there?
Hold on.
Can you give me time to catch up? I'm still on the red part.
Oh.
Is that cosine 50 on F1x?
Yeah.
Okay.
That's my cursor. Sorry. It looks like chicken scratch.
I wish I knew how to write cursive.
You don't have to write that.
Can you write your name first?
I'll do it.
That's all you'll need to know.
Yeah.
That's literally all I can do.
And then x is cosine.
Yep. Because that's the adjacent side.
Okay.
So, is this kind of like one of those f of x things?
What do you mean f? No. This isn't functions.
I'm saying like it's. I'm not saying it's functions. I'm saying it's kind of like that. Like we're.
Mm-mm.
No.
No.
Will we use tangent?
Yeah.
Yes.
Oh gosh. So like when it doesn't give us a hypotenuse.
The way to work is so like here in a second, when we get these forces, then think about it. We're going to have an x and a y component, right? But we don't have the hypotenuse. The hypotenuse is the actual net force. So we have to use the tangent to get the hypotenuse.
See, I know how to, I know that like sine is opposite over hypotenuse or whatever. I know all that, but I don't know how to look at it and figure out which one to use.
Yeah.
Okay, so like on
Like,
it.
where do I need to start at or whatever?
Like
Do I start at the angle?
Yeah.
Yes, the angle tells you everything. This is how, I know this is going to be weird, but this is how I learned to do it. So like, here at this angle, I look at what sides I've got. So this feeds out. What it feeds out to and is not apart, like that angle's not touching, I know this is opposite. The side that is a part of it, I know is adjacent.
You're smart.
And then the one that's opposite of the right angle, I know is hypotenuse.
See, I've
See, I know
never,
that
I've
too,
never
but-
understood that. Honestly,
As far as like
I know the
which-
hypotenuse is the hypotenuse, but like the opposite of adjacent.
I've always said that the hypotenuse is the heel.
Like if you're trying to find F1 sub y or whatever.
So like here,
Yeah, would you?
Okay, no, you're good. You're good. So which one is that? From this angle,
The opposite.
it's the opposite side. Which one of your trig functions uses opposite?
Isn't there sine and tangent use it?
They do, but which one uses hypotenuse? Because which one do you have?
Oh.
Okay. Okay.
Okay.
So whatever they give you is what's going to be on the bottom.
So like for F
Not always.
sub x, you use
So here,
hypotenuse over adjacent. And or adjacent over hypotenuse.
yeah.
Okay. That's cosine.
Because you're going to do, yep, you're going to do the cosine because this is the adjacent side. And that's your hypotenuse.
Okay.
Hopefully that helps. I struggled so much with that for the longest time. And then when I was in college, I think I watched a video and it showed me that. And for whatever reason, I remember it like that. You good now, Logan?
Give me just one more second. Sorry.
Okay. Now, can you explain the process where you'll write down cosine of 40 degrees is equal to F2 sub x over 500 newtons. How does that go from that to 500 newtons times?
Okay, because what I'm doing there is, so like here, I got the sine of 40 degrees is equal to F2y, bless you, because that's the opposite over the hypotenuse. I'm trying to find that.
Oh, okay. So it's
So
just
I
like
just-
using it as an equation.
Yeah, so I just multiply by 500.
Okay.
Good?
Yeah. So, are we only gonna be dealing with like sine and cosine for?
Sine, cosine, and tangent. And then you're going to do the inverse functions.
Oh,
What's the inverse?
Inverse is when you're trying to find the angle.
isn't that
Okay,
like
what's the?
secant, cosecant, and
No. Those are not inverses.
So we're not doing
Those
that,
are-
right? We're not doing
Wait.
secant.
I'm not doing secant, cosecant, or
Oh.
cotangent.
okay. Well,
What are inverses?
Inverse functions,
I thought those were.
Isn't it where you just flip them?
Isn't that one of
those are reciprocals of what you're trying to think of.
Isn't
Okay.
it where you just flip them?
That's
No.
the same thing with like the
That's
secant and
reciprocal.
cosecant.
inverse
This is-
is 1 over negative sine, isn't it?
Oh.
Oh, I remember that. Is that what they're called?
Or 1
I don't
over
remember.
Sine to the negative.
You see, I don't remember
Yeah.
any of this because we never had it.
Okay, hey, I get it. Just bear with me,
It's
bear with
right
me.
here. Hey, it's right here.
Because we're going to do it.
It's right here.
Okay?
Right here it is. E. On the first side.
Just bear with me right now.
Oh,
So you got the cosine, 40
Well,
degrees.
it is. It's sine negative 1.
yeah, sine negative 1. Correct.
To the negative
Yeah,
first
that's
power.
the first.
Negative first power,
For
whatever.
F2i. Are you talking about F2i?
Did you know that the derivative
So,
of that would be...
Negative 3.
The derivative of that would be negative 1 sine. To the negative second power.
Yeah.
Actually not. Because if you take derivatives of trig functions, that's not how that works.
So you
Well,
know something.
if it's simple-
So f of 2x
Okay.
equals 500 newtons times the cosine of
We're
40
already
degrees,
on that.
40 degrees, not 50.
which will equal to
No, I'm just letting you know you do that.
I get 383.0222 newtons.
Technically, wouldn't that be negative 2? Because it's going opposite.
Yeah, yeah, I got it.
Yes, negative 3.
It will be negative, and this is where you have to notice that. You solve for magnitude. You've got to visually see it,
Visually.
that is going in the negative direction. Therefore, that's got to be negative.
Okay,
Please,
so
please,
all students take calculus thing with the different quadrants. Does that apply to here, or is it you just kind of look at it and see?
So will the x direction always be the cosine and the y direction be sine?
Okay.
What?
Is that proper?
I'm trying to remember what the all students take calculus thing
The
was.
first quadrant, that's
I know
everything's
that's all of
positive.
them. The second
Sine
one's a
is
sine. Third is
Take
the
tangent, and fourth is cosine.
yes, but on it.
Yeah, that'd work for this.
All students take that.
So if you're going, can I ask you this? If you're going like, is
Technically, yes, you're
Okay.
correct.
where you have these, right? If you're going like this, would you use the tangent instead of sine or cosine?
It's all about what I give you, all about the sides.
So
It's
will it
all about
always
sides
be
and
sine
angles.
and cosine?
No,
No.
we still use tangent. It just depends on like.
Then when would you use tangent?
Guys, y'all are looking and wanting to know, okay, this is where, and I ain't being mean, and I love our math department, but this is where you guys have been hurt because what you've learned
We've
is
all
to do
been
one
hurt,
thing,
so-
do it 20 times, and do it well.
Men.
When you go to college, they are not going to want you to do that. They're going to want you to be able to do 20 things very well
Why are you
and know when to do them. This is different. This is why I tell kids when you ask me, do I need this? I say yes. Because I'm taking you, just like in chemistry with nomenclature. I'm not giving you, give me the nomenclature of ionic bonds. Give me the nomenclature of covalent bonds. I'm not asking you to do the one thing 20 times. I'm asking you, here's 20 problems, figure out when you need to use what to use. You are not going to have a definite answer in this. You have to be able to look at it and know when to do what to do.
That's what we're asking you.
No, you want a definite answer. That's what you're asking for.
No, I said
Will it
yes,
always
like
be
Why are you
sine and cosine?
Yeah,
Because
but
this
like
is how I get your attention.
Well, that's not
You guys have been trained to do this. You guys want to
Well,
know,
then
will it
it's not
always
our
be
fault
that? The
right
answer
now.
is no, it's not always going to be that.
It's the system is broken, okay? It's not our fault.
Hey, hold on.
Okay, but then it's my job in here. I can't use that as an excuse.
I don't
You
think
are
they'll
my
yell at
students.
us.
He's not yelling at us. He is proving his point with a
Shut up,
loud
Barb.
voice.
I'm not, okay, but I'm going
I
to be
mean,
honest.
actually.
Right here is my point. As I look and I've explained to you why I cannot give you a definite answer, and you say you're not asking for a definite answer, but you are. You want to know every time, am I going to have to use sine and cosine? I don't know. It depends on the problem.
No.
It depends on what it asks for.
Okay,
Like
when it's
whenever
like this, yeah,
Okay, you're looking at two forces like this,
yeah,
but if I wanted you to find two forces like this,
yes.
it depends on the side and angles I give you. I
Exactly,
don't
but-
know.
Ugh.
I would.
But it would still be positive and negative.
Well, the y-axis.
If
You
it was
can
going
break
this
it down
way.
in that.
If it was going this way,
I know the quadrants
You can
though.
break
At
the
least I
sides.
know the quadrants.
That's good. And I'm not mad at y'all, but I'm telling you and I'm trying to explain to you why I can't give you a definite answer in this. It's impossible for me to give you a definite answer because you have been driven to do this. That's why when students like you come into physics, it's such a struggle. You are the top of your class and you are the smartest and brightest students we have.
Thank you.
But that's
But
based
what
off
have
of the
you
broken
learned
system.
to do? You've learned to do one or two things and do it well.
Yeah.
And
Over
then-
and over.
After you've done it, they're going to ask you to do it on a quiz.
And then we throw
And
it
then you're
away.
going to learn another thing.
and then,
We
And then you gotta do it
throw
on a
another
quiz.
thing out.
And then we do another thing.
and then we bomb.
In classes
Wait, what?
And we
and in
bomb.
life, they're going to look at you and they're going to say,
I thought it was like
you need to be able to do all of this. Well, when do I do that? When you need to. Well, when do I need to?
You need
Well, it
to
depends
know.
on the circumstances.
You need to know the circumstances. They need to
You've got to know.
It's like trying to figure out if you need cash or card when you're going
So,
somewhere.
so
And-
We've
okay, it's like figuring out,
we've been conditioned to do
Oh,
yes.
things.
Pavlov's dogs.
but then
That's
that's
what I
not.
thought.
That's we can't. It's not
Yes,
our
you
fault.
can.
No, it's not.
It's not your fault, and I'm not blaming y'all, but I'm trying to explain to you, because I'm up front with y'all. I'm open with you guys. And I'm trying to explain to you. You guys are fighting me, and you feel like I'm a brick wall. I'm a brick wall because I'm like, I'm not caving. I will not change what I require you to do. Because I know in the long run, it's better off for you.
Yeah, but then when you teach us to do it that way, then we're gonna be bad at math.
No, you won't.
Hey, if we figured out something, or what are we doing, Cal?
In real seriousness, when we've been in this art
No,
class,
no.
we're now like,
Come on.
no, that depends on the reference point, and if we want to
Yeah.
make this that way, then we should be able to do that. And
I
she's
think
up
she-
there like,
She was like,
What?
well,
Well,
It's
yeah.
a different mind. She thinks mathematically,
See-
I think.
what if we use
And that means,
on
that means that we're supposed to have two different minds for this school.
what if we use the math for our 1D motion?
I was about to ask
Basically,
that.
Yeah.
what you've come down to
It
is
doesn't,
that
you get the answer, you get the answer.
there are
You do
so
both
many
ways.
different ways of thinking, and this person that thinks this way thinks they're right. This person that thinks this way thinks they're right. What's to say they're not both right?
Connor.
you would make a great
Action.
I'm
right.
Do y'all remember when you were on that
Alright, so
board?
in this, you now have the components, so we can now solve for the net force. So in this case, I have force of 1 of the net force in the x direction is equal to force 1 of x plus force 2 of x. So,
Hold on.
Like Mr. N says, unless we dig William Shakespeare up from the grave, we'll never know what it's actually about.
Uh-huh.
Mr. Howard.
So how do you know what
Um,
it's actually like? What's actually happening? You know?
When you find the net force for 1D, is it, how do you,
summation of all the forces.
so you just add all of them up?
Yeah.
Alright.
Of X.
Well, it depends, you'll be looking in y direction. You'll be in
For
one
1D?
dimension. Yeah, you'll be in one dimension though.
So it won't technically matter since you're only moving in one direction.
Yeah, I will not, I cannot break you from 1D and X to take you to 1D and Y. I can't do that.
Okay.
Mr. Hall.
Yeah.
How did we get the negative 383?
Because we got 383.02222 newtons.
So,
No, I'm saying, yeah, I know where, I'm saying where did we get it from that? Because on my calculator, I got negative 333.4690.
What did you
oh,
type in?
adding
The wrong thing.
500 times cosine 40,
Are you in radians?
I don't know.
Let me see.
Right here at where this says degree, does yours say radian?
Yes, he's in degree, or he's in radians.
I don't know how to change that stuff.
Well,
You ain't
I'd be so.
You're okay, you gotta go to mode, and then just go down,
to radians, degree.
and go over to degree and hit enter.
Yep.
That's how you change it. That's why I stress that to y'all, because a lot of people, like, when you get in college, professors will not allow you to stress that. Like, they will not stress that to you, and they'll just let you fail.
Does it?
I vote we put Connor in timeout for 5 minutes.
For what? You not.
For you being a jerk.
Okay.
Mr. Meany.
I love how y'all love each other. Alright, so the net force in
I'm
X
sorry,
direction
what?
is negative
Hold on.
125.9072 newtons. So now we need the net force in the Y direction.
627.8116.
Wow, you put that in the game.
Yeah.
F that Y. F netty.
What'd you get?
627.8116.
Yeah. That's what I got, 2 commas.
Actually,
That's what I got.
oh goodness. Oh wait, did I do that wrong?
So all it is summation of force 1 in the Y direction plus force 2 in the Y direction. And I got this number, like I've got my notebook from last year that I keep looking at and make sure we're good.
How
So,
did you get that?
That's on the
Oh, that's the
Y.
answer. Okay.
yeah, that's the answer. Like, Thomas just threw it out and I figured you guys would be fine adding 2 numbers together.
Well, no, I'm off. We'll be
Whoa,
at,
excuse me.
Yeah.
I think I.
It was a burp.
Alright. So you gotta get those values.
I got 5.
Need to actually get some of the lines.
Neither one of them is
That is
negative. Holy crap. I'm getting old. I turned 18 this year.
So then we take
It's
those,
crazy.
and that's when we do the f net x squared plus f
What?
net y
It's crazy.
squared under the
You
square.
can. It's down to you what step you want to do right here. I'm going to label something out first. You can do that next step.
So much work to do. If
What are we
then,
doing
Oh,
next?
I was so lost. I didn't realize you took a picture of it, and I was like, his hands are moving there, but they're just so still there.
All right, y'all good there?
Oh no.
Yes.
All right, so in this case, all I've done is I've wrote out the quotation system and I wrote these down. So here's what we do now. We now look at it and we need the net force. The net force is the resultant vector from these two. So this is like what we're looking at.
we know how to do
So we're
this.
going from this point, we're going to start here. Let's go to x. So negative 125.9072. So it's to the left, because we're in the negative direction, and we go over their vector 125.9072. And that's Newton. Then we have the y. I'm going to do tip to tail.
What?
So we go from the tip to form the tail of the next one, and I go up in the y direction, and this is 627.8116 newtons. I went up because it's in the positive direction. Now in this right here, that was awful.
This is where we use tangent? Do we?
Yep,
Oh, yeah.
you can.
Oh,
too
let's
late,
just get
sorry.
juicy.
All right, at this point, what we're going to do, we're going to find this is the actual net force here.
Use
Okay?
that equation.
Oh, so this will be the actual net.
This is what we're going to do. We're going to use that one equation that I wrote out to you guys on the front, which is just the Pythagorean Theorem. That's all it is.
640.3.
Wait a minute, the Pythagorean Theorem?
Yeah. What'd you say, Connor? Not
640.
Connor,
Now
sorry,
I'm excited.
Thomas. 640 point
3124.
newtons. Yes. Now, here's the thing. This is where the tangent will come in at. I always like to use as my numbers that I've done the least calculations to get. So in this case, this number is based off these two calculations. So I don't want to reuse this number in another calculation. I know we calculated these two, but there was less calculations in them. So I will use the opposite and I will use the adjacent side. I will use the tangent of that, and then I'll do the inverse tangent to find this angle, theta. Once I find theta, I'm still not done, but we'll pick up there tomorrow.
78.66. Hi, future me.
Hi, Kevin.
Alright, so this is,
Our voice is haunting him. When we graduate.
We're gonna come back in like 10 years.
It'll be like
You'll
4
still be
years
here.
from now, my brother will be a senior. He'll crack the same joke, and you'll have like flashbacks of this class. And be like,
He'll start playing
Off into the
Fortnite for us.
I remember
you suddenly
that.
fall back into the floor. It's on video again. My brother edits a montage of it, puts a funny song behind it.
Puts Fortnite
I usually
in
work
PTSD.
Liv, let's be honest. Do you really think Parker's really got taken this class?
Heck
No, Parker shouldn't be in the. He shouldn't have made it this far as is.
Okay.
If I'm being honest.
Alright, so here's the net force that we get. So that's the magnitude. Now this is the thing. This is where whenever you're dealing with like net force problems like this is a good thing. You don't have to worry about a positive or a negative sign. The issue is that these net forces can go anywhere in 360.
Is that
Why?
1627.8 or 627.8 with parentheses?
Huh?
Under-
That's 627.8.
Yeah.
This is parentheses.
Is that 118?
This is Pythagorean Theorem right here.
That's all it is.
When does a Pythagorean
Oh,
theorem get a square root?
Whenever you're solving for one of the sides.
Yeah,
A squared plus B squared
equals
equals C squared.
See, I'm used to the
A
halfway.
plus square root of A plus B Is equal to the square root of C.
Okay, I just jumped it because I knew you all were used to it, and I didn't think I had to show the whole, like, hey, let me move this stuff around, let me take the square root of this, hey.
Well, hey,
Well,
the
sometimes
thing,
life ain't that simple.
the thing
Well,
that had me on
This
mixed
whole
up was,
time, I could have done this instead of working the old problem out.
No, because you had to figure out
You
what your
had to
F and the
figure
Y
these
direction
two
was.
out in order to get that.
Yeah.
Oh my god. Not in physics, guys.
In math.
Which
I
math
meant
class
in
are we
math.
talking?
When we did Pythagorean Theorem, this whole time I could have just took
As long as you're
square root.
solving for the hypotenuse.
Yeah. I don't know.
I mean,
I'm not
the only
as
thing that
stupid
would
as
change
you
if it
think.
wasn't hypotenuse.
So here's the
You're
thing.
smart. Thank you.
Plus the B minus.
B minus, yeah. Find theta.
Oh,
Okay, so we gotta find this angle. The reason we gotta find theta is because the real angle that we need is right here. It has to come off that positive x-axis. I'm gonna call it beta.
How do you?
Theta beta.
Oh.
So it is, we gotta find theta. I like to use numbers that the least amount of calculations we need to find them. So I'm going to use this and this. So when I'm looking at this angle, I know that that's opposite and that's adjacent. So in that case, we're going to use tangent.
can you let me draw that real quick on this piece of paper?
On this piece of paper.
My other one's all crinkled and it's super small.
Okay, this is theta. That's beta.
Oh, what did you do?
Find theta.
Okay,
Exclamation
I'll do
point,
it.
exclamation
Do it after
point,
the camera's on.
Lights, camera, action.
Find
Alright.
the tangent of theta.
So you're getting that down, so pretty much you get the tangent of theta is equal to 672.8116 newtons divided by 125.9072 newtons. In this, here's where the inverse functions come in. These are trig functions, so it literally has to be an inverse function. This isn't a, well, we're just going to get rid of the tangent over there. No. You're going to multiply each side by the inverse tangent function.
No.
So, it is the inverse thing, is that just like a derivative or something? Because if you explain it that way, it's going to be easier.
I just want to know what the inverse function is.
Okay,
Ow.
1 second.
okay.
Don't say anything that I'm over. Just stop it.
Why is it me?
I just pressed the pause button, right?
Where's he going?
Just press the pause.
He's gonna probably get Miss Albright or Miss Cole one for the
Yeah.
Are you doing that one?
For what?
Okay.
Hi, future me.
Hi, Kevin.
Fucking cold.
Now we have to stop it again because of you.
At this point, this class is kind of like
Okay, so in this is it's not an inverse. Okay, it's like the opposite of. So this is how Miss Albright explained it to me. Because I'm gonna try to explain it to you how she explained it to me. Normally, you know the angle. In this case, you don't know the angle. So when you're trying to find the angle, you usually do it in the inverse functions. I am right in saying it's like we're gonna multiply both sides of these by the inverse function.
What's the
So make
inverse
this
function?
disappear, and this. It's literally what you're going to throw in. It's the function whenever you're trying to find the angle. Between this.
I swear if he says secant squared.
It's not secant squared.
Yeah, if he was to say.
I'm not dealing with secant.
I've heard
That's why I'm
secant.
saying. That's why I'm saying it's not the inverse. Because if I took the inverse of that, they got cotangent. I'm not dealing with inverses. So
I thought you
Or
were
find
saying
the
inverses.
derivative.
not
I feel like I'm
He needs the right terminology.
not the reciprocal. It's not the reciprocal. I'm sorry.
Nor
Okay.
the
The
derivative.
reciprocal.
Is it tangent to the -1?
Yes.
The negative one.
So
It's
in
the
this.
inverse.
The inverse function is literally just
Why do these
the
classes
trig
have to be so
function of the
close
negative
together?
It's the square root of tangent.
Tangent -1.
So multiply both sides by the inverse function, the inverse tan function. That cancels,
So
which
now we
leaves you with just theta,
-1.
which will be equal to the inverse function.
Hold on, you're writing too fast. Okay. Oh, God.
So if you multiply, then you're left with this theta.
Yes. Because this is us finding that angle.
Do we go in degree?
Do it in degrees, don't do radians.
Yeah,
I know what it is.
Okay.
Okay,
So whenever you're looking for it,
When's our study session?
Yeah, that's a good question.
I had to move it to Tuesday.
Tuesday.
Now I got something going on Monday.
So it's like,
So what definitive time do we have? It's on video for everyone to go back and watch. Tuesday at what time?
After school.
Okay.
Yeah, I'll try to do this.
Tuesday after school.
So in this is what you're looking at. In your
For-
calculator,
Good?
whenever you're trying to get this inverse function,
Is it good?
just help with her.
isn't
Let's
it
go with
second tangent?
That's all it is. So hit the second function.
As far as I know.
Come here where it says tan. You'll see that tan to the -1 up there.
Fancy.
When we get the answer, would it be in degrees or would it be newtons or?
Degrees. But
Okay.
then you got to combine the two things together.
So
So then we'll type it in.
Let me see. That 125 is a negative.
Please tell me you got 78.6.
Yeah, that one.
Yeah!
Now I have the angle.
Ooh, Connor.
What?
Ooh.
So
Oh,
theta.
that's what I need to say.
Hold on, wait, your numbers are slightly different than mine.
What numbers?
Oh,
You just used the 4 places over there.
I didn't put, hold on, move the calculator real quick.
Is it Newton?
Oh,
Degrees.
I've been leaving the 6 off of the 8116.
Because that's the degree of the...
That's theta. Now we got to find beta.
Beta.
So we know theta plus beta.
We're going fishing.
So, but then we have to do 180.
180. And then we have to do theta.
180 minus theta.
Be equal to beta. So now beta
Is
equal to
beta an
180
actual
degrees.
Yes.
Yeah, it's a reflector.
Beta.
Minus 78.6598%.
Beta.
Hold on.
101.
So if that 125 number is negative, that would leave you with negative 78.6598. So what
You
you
do
end
not
up,
carry the negative number. You took care of the negative number when you went in the negative direction.
Connor?
I'm sorry.
Yep, Connor.
This is science, not math. We took
Liv,
care
you
of the
shouldn't
negative.
ever listen to Connor. Don't.
I don't know.
Alright,
Miss
next
Val
time.
seemed pretty excited for the math in this class.
Next time you ask me a question, I'll answer.
What?
I said next time anybody asks me
You
a
got to
question,
stop
I'll
the
answer.
video.
Next time I ask for what? What am I going to ask you for?
Okay, so in this, if you're wondering, like my degrees is a little different than yours, I literally used the answer function in the calculator that took that off snap.
No, I would, the 627.8116, I was leaving the 6 off the end of that number, that's why.
Okay. But on this, I took this whole answer here, so I did 180 minus second answer, which leaves that whole thing in there. So if you got something just slightly off from that, that's okay. You're still correct.
So question. Now that we have theta and beta, what do we do?
What else
We
do we have to
find-
do in this?
We have
We got to combine them together.
our force
So- F net.
So we got the whole,
equals
World.
640.31424 newtons at 101.3402 degrees.
Huh?
what?
So you get the net force is 640.3124 newtons.
I can't.
That's the force we solved for.
Wait, why would that?
At
I'm so confused right now. You're trying to find.
net force.
Yeah, but
We solved the degree thing, so we knew which
you were
direction.
finding sides. Then you use the sides to find the degree of the angle.
Because you have to find the angle because that determines direction now.
You don't remember doing that? We done that. For
No,
like,
but how could you find the angle without finding the other two angles?
Are all these problems gonna be this
Because
long?
I used a trig function.
Or is
No.
this, okay, so this is
Some of
like
them
you giving
will
us
be
the
longer.
hard one and
Did you say some of them could be
make it
longer?
easier?
This seems longer too because I'm going slow.
Okay.
It's took up 1.5 of my paper.
1.5.
Okay,
I take notes very good.
so this is the thing. It's a magnitude of 640.3124 newtons
That's our
at 101.3402 degrees.
Bada bing, bada bing.
Okay,
Bing, bing, boom.
that is the final answer. If you use the reference angle, you're wrong. If you don't include an angle, you're wrong. Angle takes care of direction here.
Angles
Because we can no
matter.
longer do a positive or negative.
Angle lies matter.
Are we-
Because it's in two dimensions.
So are we always going to be using tangent, or will we do like the second
It
sign?
just depends on
You
what we
start
have.
from- you start from
You
section
can do
AO
different
and
ones.
then
And technically, in this, you have all three sides.
Okay, but
Once you solve for this. Once you have that, you technically could have used the inverse sine, the inverse cosine. It's whatever you want to use.
so like,
No, you won't always use tangent, but probably.
but I'm always
Why are
going to
you
press.
using-
I'm always
Okay,
going to
wait,
press
why are you
second,
using
one of trig
beta
functions,
instead
and
of
then plug
beta?
in the numbers.
Yeah,
Correct.
as long as
Okay.
you use the right numbers.
Why are you using beta instead of theta for the angle?
Because I already used theta. If I look at you and said, let's find theta, you'd be like, which theta?
You said theta two.
Yeah, theta 2.
Well, just
O2.
call it alpha.
O2.
For
That's
teta.
Because
not
then
what
we
I
have a whole
meant.
frat house,
That's-
so we don't need all that on a paper.
That's not what I
A
meant.
frat house.
Yeah.
Omega.
Alpha.
I mean,
Beta,
like,
theta.
I get
The
it.
angle. Why would we use the
This
outside
is
angle
the
instead
physics
of
frat
the
house.
inside
Alpha,
angle?
beta, theta.
Because you can't use a reference angle. Think about it. That's a reference angle.
Mu.
That's not the actual angle. Whenever you
Mu
take
theta.
measurements of angles, where do you always start
Mu
from?
beta.
Positive x-axis. That's
I'm sorry, but I've never
78.65.
went
Could be
over this.
78.65 here. Could be 78.65 here. 78.65 here. 78.65 here. It's all reference angles.
Can't tell you that I've ever learned that before,
Maddie.
Oh my
Mr.
God.
Hall.
Holy
Things are tense.
good God.
Maddie, where is 0 at?
That's
It's at that one.
It's at here, right? It's at right there. Okay, so in order to get this angle, you have to, do your supplementary
Okay.
stuff.
Well, I know how to do
And-
that. The whole thing was the reference point.
Yeah, you can't, you're not referencing that way. You always start from the right and go around.
Think about it. What quadrant is this?
1,
1, 2,
2,
3, 4.
3, 5.
So everyone's
You were
Tom.
going so strong.
everyone you look at. 1, 2, 3, 4. Where did you start at? You start there at the positive x-axis. Sorry, buddy. You good?
Thank you for explaining that to me, Mr. Hall.
The time you need.
You're welcome.
Because I honestly can't say that I haven't been taught
So
this.
you're
Off the top of my head.
Thank you for explaining this to me, Mr. Hall.
See you, Brett.
You must be obsessed with
This is just so because
What happened to
like
Christy?
I'm mixing up the calculus stuff.
I see her walk
MIA.
on the
This
first
stuff.
period this
Cause
morning.
I can remember the calculus.
What's that?
She's
I got the
Christy
f of x and g of
Is
x.
she okay? Have
This
you heard
stuff-
from her?
Pull them together.
Is she okay?
She's okay.
Can we go check on her?
She's not here.
Oh.
Is she sick?
Nope. She's doing just fine.
Oh.
Oh no.
So,
We've lost one.
Connor, pause the video.
question.
Oh no. It's all going downhill.
Okay, here's the thing. Yeah, I want to use this as an example. If you wanted to put this situation into equilibrium, then you have to have, it's just like everything else, it has to be equal in magnitude, but opposite in direction. You are used to equal in magnitude, so the number's the same, so that number will be the same, and you're used to opposite sign. But now it's no longer that.
It's
This is
opposite
here, it has to
degree.
be opposite direction. So it's got to be down here. Now what's the easiest way to make sure we're opposite of this?
360 minus the 72.
What?
What? No, maybe. I don't remember.
You flip it down and then flip it over.
I draw a straight line and then I just start plugging.
Perpendicular angles.
I don't remember. I know that.
180 plus.
Just add 180 to it, because what's half of the whole thing? 360. So if you add 180 to that angle, it's going to take you directly across from it.
Are we ever going to be forced to do
It's
that?
gonna say, yeah.
Yes.
Okay,
That's why
it
I'm
would
forced
be.
that in.
It
Now,
would
if
be.
you're in an area where, you,
We
like, let's say
need
you're
to
down
find
here,
that
and it pops you
exact
back over here,
point.
if you have a number greater than 360, then use some common sense here. You're going to start all over again.
But you
Something
add
minus
180
one,
to
correct?
the
one
to
that's bigger.
the beta, not the theta.
Yeah, 180 to beta.
Or
Because
you
that's
could
the
add it
actual
to either, but it would just go like either way, right?
It would
Because
still,
if you added it this way, it would go like this.
You'll need to do beta if you're just going to add it, if you're not going to solve for anything.
Okay.
Yeah. no,
Because beta is
fine.
the actual angle coming from the positive x-axis, so the reference point will be the same.
But I
So
feel
from
like
there,
if you-
add 180, boom, you're here. If you go here, add 180. I know you're looking and saying it's going to put me in the same area. Mathematically, it's not going to show that.
But if you go like this, if you subtract 180 from the reference point.
it'd be the same thing, but
Sure, but then
logically-
you're not going to get. I'm trying to make it a lot simpler for you. If you subtract 180 from this, you're going to end up with
Well,
a
I'm
negative
not
number.
simple,
As
obviously.
soon as you give me a negative number, I'm going to look and say, wrong.
Oh my god.
Everything has to come from terms of the positive
I thought
x-axis.
it was all based on your reference point.
Yeah, but there's certain rules within using your reference point. Like we're going to go from the positive x-axis and go around counterclockwise. We're not going to go clockwise.
Goodness gracious.
That is.
That's
Wow.
discrimination against my reference point.
Why is calculus and physics so close together, yet so far away? Close enough to make me confused.
yeah.
But
Actually, the truth of it is this is trick-based physics, or is it calc-based physics?
Now, huh?
Listen, I'm
AP,
saying
if you took AP